Hey guys, today I'm just going to do a quick lesson on what we're going to call is the instant rate of change or instantaneous rate of change. I think in Algebra 2 you did average rate of change, which is essentially just slope. You don't have to do these warm-ups, but if I gave you 2 points and I asked you to find the slope of it, essentially what you would do is just the y2 minus y1 over x2 minus x1, x1, and you get the slope, right? It's a change in the y over the change in the x, and that gives you the slope. So even for things that are not lines, like this one, we have a quadratic here. Just because it's not a line doesn't mean it wouldn't have an average rate of change over a particular interval, right? So if I said I want to know the average rate of change between an x coordinates of -3 to 5, so over that interval, I could do that, right? And all it would basically be this, right? So this is the graph. And if I had, like, -3 turns out to be 32, right? So if I had um, if I had -332, something like right around there, and then I had the coordinate point of 5 comma 40, right? Let me just see. So -3, let's just say that's -332. And then over here we have 540. Even though the graph goes way down here and then it comes back up here, all I would be looking for is if I drew a straight line to connect that, what is the slope of that line? And that's the average rate of change. So it doesn't really paint a clear picture of what's happening in the graph. All it really cares about, what was it at the beginning, what was it at the end, and your average rate of change is the slope, essentially the two of the line that would connect those 2 points. So in this case, it would just be a slope of 1, but that's how you kind of do it. So if I gave you like a real world example, um, we have this small airplane type of thing. This is the graph essentially. You can read that prompt, but it gives you the graph, right, as well as the equation. So let's say, I want to know the average rate of change or average velocity in this case, since it's miles, right? Again, it's y over x, so miles divided by hours or miles per hour. So my answer, it's the y over the x, so in this case is miles over hours. My answer is actually going to be a speed, so it just says velocity. So, and that's kind of neat, right? A slope of, y over x gives you a speed in this case because you have a distance divided by a time. So, if I wanted to know the average rate of change of this plane, let's say between 1 hour and 5 hours, I could figure that out. I would need to know what this coordinate is, and I would need to know what this coordinate is. And even though it doesn't connect in a straight line, although it's close, I need to connect it with a straight line to kind of figure out what the slope of that line would be, which would be the average rate of change or average velocity. So in this case, right, this line right here is drawn in for us. That would be the line that would connect this one coordinate with this coordinate of 5 with the x. And that line that we draw in is called a secant line. You may hear that next year. But, that secant line, what we're trying to do is find the slope of that secant line, and that tells us the average rate of change. Right, so the difference in y's from this point to this point, the difference in y's is 244 miles. And the difference in x's, or the change in x's, is 5 minus 1, so it's going to be 4. So 244, right, which is the y, divided by 4, which is the x, will give us an answer of 61. And again, the y is the miles divided by hours, or miles per hours, right? The y is on top, the hours is on bottom. So what does that tell us? It tells us that this, toy plane or whatever, between 1 hour and 5 hours, on average, flew 61 miles per hour, right? So that's on average. Now at individual points, like right here, it actually might be flying faster than 61 miles per hour. Here, it could be flying slower than 61 miles per hour. But over the course from 1 hour to 5 hours, it was averaging 61 miles per hour, right? And that's kind of what, was probably touched on a little bit last year. How it's different with this lesson is basically we want to know what things are at an instant, right? So maybe for this past question, how fast is the plane going at 3 hours, right? What's the speed exactly at 3 hours? And that's hard because you don't really necessarily have 2 points to go off of. You just want to know what the speed is right there. Like what would be that slope if you could draw like a slope right at that tiny little spot? So there's a way to do this next year in calculus. That's not what I'm teaching today. I'm going to tell you a different way that you can kind of get at it, right? So we have here an object is traveling s yards in t seconds according to the following function, s equals 50 divided by, or 50 minus 50 divided by t. I want to know how fast that object is going at exactly 2 seconds. You say, well, how could you possibly do that if you need 2 points? Well, you still kind of need 2 points for what we're doing today, right? So what are the 2 points we're going to use? Well, we can be clever about this, and if you might be thinking about this on your own. What if we did an interval of 2 and then like right after 2, so 2.01. That's pretty much an instant, we can say in math, right? Like the difference between the ball rolling at 2 seconds and rolling at 2.01 seconds is probably not very much. So if we take these two x values, I could plug them into the equation and get two y values, and then I would actually have 2 full coordinate points, right? So if I did 50 minus, 50 divided by 2, right? 50 divided by 2 is 25, 50 minus 25. I get 25 on the dot, right? So if I plugged in 2, I'd get 25. Now if I plug in 2.01, what I'm going to do, what I'm going to do in this same exact thing. All right, what I'm going to do in this example is, I'm going to quit this. I'm going to do 50 minus 50 divided by 2.01. It's probably not going to be very different than 25, right? I get 25.1244. I'm actually going to use 4 decimals here, and I'll show you why in a second. So 25.1244. All right, so I get 25.1244. So that's like the y coordinate if I plug in this for an x. So if I, even though it's such a small window, right? I'm not sure what the graph necessarily looks like, but, even if it looked like, something like this, right? Right there is 2 seconds, and then like right there is 2.01. I want to find the slope right at those 2 points, right? So I have 2 y coordinates, I have 2 x coordinates. I can find the slope, even though, these numbers are really close to each other. That's okay. So what it is going to be the y coordinates. So 25.1244 minus 25 divided by the x, the change in the x coordinates. So since I started at 25.1244, I'm going to start with 2.01 minus 2. And I will get, 0.1244 over 0.01. And dividing by 0.01 is the same thing as multiplying by 100. So I will actually get an answer of 12.44. So you can kind of see why I kept 4 decimals. That way my final answer actually is going to have 2 decimals, because every time you're going to end up multiplying by 100 or dividing by 0.01. So 12.44, again, it's the y's over the x's. So the y's, in this case, represented yards, or s's, I guess. And t's, or the x's, represented seconds. So my final answer is a y over an x, so it's going to be 12.44 yards per minute. So I can tell you at 2 seconds, that ball is pretty much rolling 12.44 yards per minute, right? Minute? Should say seconds, 12.44 yards per second. But you kind of get the gist. Now, overall, right, if I started at 0 and went to 10 seconds, it's probably not rolling 12.44 yards per second from 0 to 12, right? The ball is going to slow down. We don't know what the average speed is over the course of until it stops. It's probably stopping at some point. But I know that right at 2 seconds, it's going to be about 12.44 yards per second, right? Is it going to be more exact if I use 2 and 2.000001? Yes, it would, right? But for here, we can just use 100. That's pretty much an instant. So we have a couple other questions here. You can pause this, and I kind of want you to give it an answer, but you're estimating the velocity of a basketball and then the temperature in a room. And so you can pause it, and then basically when it's done, I'm just going to reveal the answers, and then that's pretty much it. So this answer here We have an answer of 7.84 feet per second. The ball is going to be going at that velocity at a half a second into the shot. And then here at 3 minutes, this room is going to be 12.81 degrees per minute, right? Oh, so first question, the instant rate of change at 5 minutes was 12.81 degrees per minute. And then at 3 minutes, it was only 5 degrees per minute. So you can kind of see how the temperature changes as time goes on, right, at certain instants. So your task for this one is I want you to create your own question, asking both an average rate of change and an instant rate of change question. Or a fun other thing you could do if you really wanted to, and maybe you were doing it anyways for like a gym class or something like that. But if you do a workout, right, and then like every few minutes, just measure your heart rate. Like you can just take your pulse for like maybe 10 or 15 seconds, and just jot down what your heart rate was over that time, and do that throughout the workout every once in a while. Right before you work out, it's probably going to be pretty low. Then after like you do a cool down, it's probably going to be maybe a little bit higher, but still not as high as like the most intense part of the workout. So all along the way, you're going to have these different y coordinates or heart rates at different times, or x coordinates. And then what I want you to do is find the average rate of change from beginning to end, but then pick a different time that you did not take your heart rate, and just looking at the graph, try and calculate, like if you wanted to graph it, try and calculate what your heart rate would have been, or the instant rate of change would have been at that specific time. And then you can submit your questions, or just give me a description of what you did for your workout, and then your answers to those questions on Schoology. Thanks, guys.